let's take a look at a couple of examples of using the chain rule in conjunction with the quotient rule. So let's remind ourselves that when we take the derivative of a fraction and we apply the quotient rule, the derivative of a function with f over g is the derivative of the numerator times the denominator minus, remember this is a minus, the derivative of the denominator times the numerator all over the denominator squared. Also, we'll need to remember that taking the derivative of a function that is a composition, so f of g of x, we take the derivative of the outer function and leave the argument alone, and then multiply by the derivative of that argument. So let's go ahead and take a look at a couple of examples. In our first example here, we have y is equal to 5x over the quantity 2x to the fourth minus 1 cubed. So let's go ahead and get started. So dy dx is equal to the derivative of the numerator. The derivative of our numerator, 5x, is 5, times the denominator, so 2x to the fourth minus 1 cubed, minus the derivative of the denominator. So when we look at the denominator, we can see that we basically have a cubic function where the argument is 2x to the fourth minus 1. So when we go to find the derivative here of this denominator, we will want to use the power rule to deal with the fact that we have a cubic function. So 3 times our argument squared, and our argument is 2x to the fourth minus 1, and then times the derivative of our argument. So the derivative of 2x to the fourth is 2 times 4x cubed, minus the derivative of 1, which is 0, so we'll just leave it there. And then this is all over our denominator squared. So 2x to the fourth minus 1 cubed, and then we're going to square that. At this point, we're finished taking the derivative, and let's go ahead and clean this up, simplify it a little bit. So dy dx is equal to, let's start with the denominator. In our denominator we have 2x to the fourth minus 1 cubed, and then that is raised to the second power. So in the case where we have a power raised to a power, we multiply those exponents and we end up with 2x to the fourth minus 1. 3 times 2 is 6, so that's the sixth power. Next, we have a common factor of 2x minus 2x to the fourth minus 1. And in one term we have 3 of those factors, and in the other term we have only 2 of them. So we will be factoring out 2 factors of 2x to the fourth minus 1 squared. Okay, so from our first term, we still have this 5. And we took 2 of these factors of 2x to the fourth minus 1. So there's still one of those remaining. So we will have 5 times 2x to the fourth minus 1. And then minus, and we still have this 3. And we still have this 2 times 4x cubed. And that's it. Okay, so a little bit more simplifying to do. We can simplify. We've got 2 factors of 2x to the 4th minus 1 in the numerator. And so that can simplify with the 6 factors we had in the denominator, and that will leave us with 4 of them. We can also distribute this 5 into the 2x to the 4th minus 1. So let's see what we end up with. So we have dy dx equals, here's my fraction line. My denominator is 2x to the 4th minus 1 raised to the 4th power. We have 10x to the 4th minus 5 times 1, so minus 5. And then we have 3 times 2 times 4, so 6 times 4 is 24, minus 24x cubed. So there is our derivative of 5x over the quantity 2x to the 4th minus 1 cubed. So let's take a look at our second example. Notice that in our denominator we have a radical, a square root. So before we apply our quotient rule and our chain rule, we need to rewrite that in its exponent form so that it's ready for applying the power rule. So we'll have 4u over the quantity u squared plus 1 raised to the 1/2 power. So let's go ahead and find our derivative. So g prime of u, taking the derivative of the numerator from using the quotient rule, derivative of the numerator is going to be 4 times the denominator, so u squared plus 1 quantity to the 1/2 power, minus the derivative of the denominator. So our denominator is something to the 1/2 power. So when we take and apply the chain rule here, we will deal with the 1/2 power first, and then our argument or our inside will be the u squared plus 1. So derivative of something to the 1/2 power is 1/2. Leave our argument alone, then 1/2 minus 1. 1/2 minus 1 is negative 1/2. So this is going to be to the negative 1/2 power. Let's see, our argument was u squared plus 1. So that takes care of the fact we had something raised to the 1/2 power. And now we multiply by the derivative of our argument. So our argument is u squared plus 1. The derivative of u squared is 2u. The derivative of 1 is 0, so that would be 2u plus 0. And we'll just keep it as 2u. So there's the derivative of our denominator times our numerator, 4u. And then this is all over our denominator squared. U squared plus 1 to the 1/2 power squared. Okay, so we're now done taking the derivative. Now we can simplify things up a little bit. So first of all, let's take a look at our denominator. I have u squared plus 1 to the 1/2 power and then squared. You can think of this in one of two ways. Either we have the square root of something and we're squaring it, which gives us the argument itself, or you can think of taking your exponents, 1/2 times 2, and 1/2 times 2 is 1. So either way, our denominator becomes u squared plus 1. So g prime of u is equal to, now my denominator is u squared plus 1. And now let's look at our numerator. We have 4 times u squared plus 1 to the 1/2 power. Over here in our second term, looks like we have a 1/2 times a 2. Those multiply to give us a 1. So it looks like in our second term that we have negative 4u and another u, so u squared. There's a u and a u, so u squared. So 4u squared over u squared plus 1 to the negative 1/2 power. So notice that we have a fraction in our second term of our numerator. So what we can do is get a common denominator within our numerator. So that would look like g prime of u equals, we're going to have 4 times u squared plus 1 to the 1/2 times u squared plus 1 to the 1/2 over u squared plus 1 to the 1/2 minus 4u squared over u squared plus 1 to the 1/2. And I just noticed that I had this negative still there. So let's get rid of that because I have moved it to the denominator. That exponent is no longer negative. All right, all over u squared plus 1. So let's see what this looks like. Our main denominator is u squared plus 1. Within our numerator, we now have a denominator that is u squared plus 1 to the 1/2 power. And now if I combine my two numerators, this first term minus this second term, let's see what happens. So u squared plus 1, square root, 1/2 power, square root of u squared plus 1 times square root of u squared plus 1. That's going to give us u squared plus 1. So we have 4 times u squared plus 1 from our left-hand term minus 4u squared. Now we're almost there. So our derivative g prime of u is equal to 4u squared plus 4, distributing this 4 into the u squared plus 1, minus 4u squared over u squared plus 1 to the 1/2 times, and now we're going to multiply by the reciprocal of our denominator. Okay, so if I multiply by the reciprocal of the denominator, that's 1 over u squared plus 1. So keep in mind that this u squared plus 1 can be thought of as u squared plus 1 over 1. All right, 4u squared in my numerator and a minus 4u squared in my numerator, those add to 0. And I'm left with a 4 in my numerator. So g prime of u has a numerator of 4. And then my denominator, notice that the base is the same. I have u squared plus 1 to the 1/2 power times u squared plus 1. There is an implied power there of 1. So when I multiply those two bases that are identical, I will add the exponents. So I get u squared plus 1 to the 1/2 plus 1. 1/2 plus 1 is 3/2 power. So our derivative of our second function is g prime of u is equal to 4 over the quantity u squared plus 1 raised to the 3/2 power. I hope this is helpful.